Hello everyone, and welcome back to this series in which we are going to learn about the AI agents from their theoretical perspective as well as from their practical perspective as well. And from our last video, if you remember, we have get to know that how the agents work, what are the basic architecture of how the agent works, and we learned about that what we known as what are the percepts, what is known as the agent function, and what is known as the agent program. And at the end of the previous video, we discussed that we found out that what are the rational agents and how we can define that what does rational agents ideal function will be. And at the end of the video, I also leave a question that how we can define an agent function, or how we can define an agent as good agent, as a bad agent, as an intelligent agent, or as a stupid agent. So in other sense, what I wanted to discuss in this particular video is, given a rational agent. So I have my rational agent with me, and what actually is a rational agent is one does the one agent that does the right thing. Okay. So we have the rational agent with us, and we know that it means that it does the right thing. But how we define the right thing? That's I think the fundamental question. It does the right thing, but how we define that a particular action is taken is considered to be right. Hmm. Like, what does it mean to do the right thing? That question I think we need to ask. So if I consider, let's say this is my main agenda of this particular video. And what does it mean an AI agent to do the right thing? And okay, so the solution to this is that what we coin the term as, that is known as that is known as consequentialism. Mhm. So what does the consequentialism means? It means that we evaluate an agent's behavior. So given an agent, it might be a rational agent. Given an agent, AI agent, uh, we evaluate the agent's behavior by its consequences. So given an agent, what it does, it perceives certain action from the environment. It took some action based on whatever it has perceived, and gives some action again back to the environment. Now, what are the consequences of this particular action? We evaluate an agent behavior on the basis of this particular action. So it is known as consequentialism. Okay. So let's say, given an agent, if it is plugged down in an environment, so let's assume I will draw one figure out of it. Let's say this is an environment, and an agent is plugged in an environment, in this particular environment. So what will happen? It generates a sequence of action according to whatever the information that is going to receive from the environment. So it is going to receive certain information, certain percepts from the environment, and now on the basis of it, it will take some particular action. Now the thing is, once it takes a sequence of action based on the sequence of perception, hmm, based on the sequence of action, and these actions again, the agent is doing on the environment, then it means there will be shift in the states of the environment. So initially the environment might be at some another state, but when an agent does a sequence of action on the environment, the state of the environment will shift from one state to another state. So now the environment is at some another state. Okay, it might be at A and B2. So how we define whether that agent has done the right thing or not? We determine that whether this particular environment, the new environment, is whether it is desirable or not. Hmm. So if the sequence is desirable, then the agent has performed well. And that particular notion of desirability is captured by performance measure that evaluates any given sequence of environment states. So, so given an environment, it does a particular action, and whether this particular sequence of action is desirable or whether it is right or wrong, it depends upon that how the environment has shifted from one state to another state. If this particular state is a desirable state, then we say that this particular sequence of action is also desirable. So that's how the consequentialism work, and that's how we define the performance measure. That's how we define the performance measure of an agent. Okay. Performance measure of an agent. Okay. Okay. Now, what is the next thing? But again, that's some. I think you might be a little clear about it. How we define the performance measures in particular agent. But again, let me let me bring more clarity into it. Okay. So what I told that if this particular state is desirable or not, if it is desirable, then the sequence of action is we say that that particular sequence of action is correct, and on the basis of it, we define the performance measure of an agent. But how we decide that whether that state is desirable or not, and what is desirability really means in this case? So again, it's from, I think we are moving from this all AI agents or agentic AI framework to a more philosophical kind of questioning or logical thinking. But I think it's important, and you get to know it that why I'm going more into the philosophical aspect of designing the AI agents, and rather than on the first video, I might have given some theoretical basis and directly jump onto the practical implementation. But I think these understanding help let you build a clear understanding, give a clear understanding of very real world problem statement on which you are going to build an AI agent. Okay. So that's why I think these philosophical question needs to be answered, needs to be clear. That's I think. So what does desirability means in this case? So desirability really means that we as a humans have desires, yes, and we have preferences of our own. Okay, so I like tea, someone like coffee, so they everyone has their own preferences. So that particular notion of desirability or rationality, as applied to humans, has to do with their success in choosing actions. Okay, so what it really means that the notion of rationality which are applied to the humans are related to their success of choosing action that produces sequence of environment states that are desirable from their point of view. Okay, so it's like personal preference. For me, this state could be desirable. For other person, it might not be desirable. So it's like we are our own we have our own personal preferences. What is a desirable state and what is not a desirable state? Okay. Okay, but humans can make the choice. Yeah, that's I think that's the inherent nature of the humans, that they can decide that what is desirable for them and what is not desirable for them, that they can decide. Hmm. Okay, now I will bring a certain autonomy into it. Now what does the autonomy here means? I will ask a very simple question: can machine decide on its own? Given a machine, can it decide on its own that whatever the sequence that the machine has done, and because of which there is a change in the environment states, whether that state is desirable or not? Can the machine decide on their own? Humans can decide it, that I want this, that I want this, I like coffee, I like tea. But can a machine decide that whether whatever, because of whatever action that machine does, there is change in state in the environment, and whether its state is desirable or not? Can the machine decide it? Hmm. Okay, that's I think a bigger question. So the answer is yes. Machines, on the other hand, do not have desire and preferences of their that we know. And the performance measure is initially at least in the mind of the designer of the machine. Yes. So whoever have designed the machine, the performance measure of that particular machine is in the mind of the designer. And on the basis of it all, on the basis of whatever the performance measure that designer has kept in the machine, on the basis of that objective, the machine will take the action. Okay, so here the autonomy is, we can say it's an autonomous AI agent. But again, that autonomy comes when a designer has put in a particular performance measure in the machine. Yeah. So, um that's how the human and machine differ. Okay. Okay. Now, the next thing is that I wanted to discuss is related to the same thing about the performance measure. But let's make it a little more interesting. Let's learn about what is King Midas problem. King Midas problem. So you might have heard about it, but I will just rephrase it or let your memory jog into it. That what does this problem particularly means and why we are discussing this in the first hand. Okay. So, if you remember that we in the last video we discussed that we have, let's say we have a vacuum cleaner world in which we have two blocks A and B. There is a vacuum cleaner, and in which there are few particles here, and the we define an agent function in that case. That if in a particular block the vacuum cleaner is there and it finds that the particle lies, then it if the particle is there, it cleans it. If it is not there, then it moves to the next block. That's how we have defined the agent function in this case. Okay. But in this vacuum clean, this example, the vacuum cleaner agent, uh, we can define a performance measure out of it. So what could define a performance measure is, um, the amount of dirt cleaned in a single shift. So let's say I define the performance measure that what is the amount of dirt that is cleaned in, let's say, per 8 hour of work that is done by the AI agent. Hmm. So if this particular agent is rational, so given if this particular agent is a rational agent, hmm, so it means it do the right thing. It means that whatever you ask that particular agent, it will do that particular thing only. That's correct. Because a rational agent can maximize this performance measure by cleaning up the dirt. By cleaning up the dirt, yes. But I think there is a little twist in here. Suppose we define the performance measure in this case is the amount of dirt cleaned per 8 hour. Okay. But a rational agent can also think in this way that I can maximize this performance by cleaning up the dirt and then again dumping it back on the floor and then cleaning it up again. So so I think this performance measure in this case will go up because once it clears the dirt, then to maximize this performance measure, the amount of dirt cleaned per 8 hour, what it will do, it will again just dump the dump the all the dirt particles onto the ground and then again clean it up. So in 8 hours the amount of dirt cleaned per 8 hour will go up, and that's how the performance measure will indicate that the AI agent has done a lot of work. But is it the right thing? And I think it's not the right thing. That's not how the AI agent or any other kind of agent should work. There could be another scenario also. Hmm. Um, hmm. What could be another scenario? That given so the another scenario could be that let's say there is a reward for each and every dirt particle that is collected by the vacuum cleaner. So I can define my performance measure on the basis of that reward function also. Hmm. So, so the another performance measure. So this could be one performance measure. There could be another performance measure that I can define is that that reward the agent for having a clean floor. Okay, so I can reward the agent if I have a clean floor. Hmm. So reward the agent on the basis of clean floor, on the basis of clean floor. So if the agent does cleaning of a particular floor, then I can reward the particular agent. Hmm. But again, there is a catch in this, that let's say the agent has to do 8 hours of work. So what it can do, it can do mediocre work throughout the 8 hours. It means, let's say, so it can do a very mediocre work in the first 1 hour, then in second hour, then in third hour, and goes on to the 8 hours. And this is how it get the same reward as compared to another function in which it does the work only for, let's say, 1 hour, but it is collect the same amount of dirt in that particular 1 hour, and in that particular 1 hour, but the award it will get would be the same, because the performance measure is now defined at whether that particular agent has cleaned the floor or not. So one agent is doing a mediocre work every hour for 8 hours, and the another agent is doing a very good amount of work in 1 hour and clean the same amount of clean the room in the same way. So now in this case, what would be the best ideal case? So you understand the bias here. So it really, how the performance measure we define in the machine or in the AI agent, it really affected how that particular agent is going to behave. Hmm. Okay. So it's really a very, I think, a very meticulous task to define that what the performance measure in particular agent would be. Okay. And I think as a general rule, so there is a particular general rule you can like just a general rule is that to better it is better to design performance measure according to what one actually wants to be achieved in the environment, rather than according to how one thinks the agent should behave. So what does it mean? That if I need to define a performance measure, I should not define it on the basis of that how the agent or the AI agent should behave. I should not define on the basis of this. I should define the performance measure on the basis of how it going to affect my environment. So the performance measure should be on the basis of the environment rather than on the behavior of agents. Okay. Okay. So after discussing all this kind of thing, I think you might be have a better idea that how we define what is a performance measure in an AI agent. But again, there are certain caveats into that what we have discussed up so far. And one of the caveat I can discuss is, let's assume, so I have tell that the one of the performance measure could be that whether the agent is able to clean the floor or not. But what actually you mean by the clean floor? So there are depth to the understanding of the performance measure, and there is philosophical depth to it. Because because in this case also, for example, that notion of the clean floor is based on the average cleanliness over the time. Like, let's say you observe the agent function over the time, and you define the clean floor on the basis of average cleanliness over time. Yet the same average clean, but as we discussed, that the same cleanliness can be achieved in two different agents. One which does a mediocre job, and one which do it very energetically. One do it very energetically, let's say completing 1 hour, and then take break for 7 hours. And there is another AI agent which does the same amount of work but do a mediocre job in every hour and do the same amount of work in 8 hours. So that we already discussed. So there are certain caveats still into play, and I think we cannot get rid of all of it, but we need to. I think we need to observe all of them, and we need to find the best suitable performance measure on the basis of how the performance measure is going to affect my environment, not on the behavior of the agents. Best suitable performance measure on the basis of environment. On the basis of environment. Okay. I think by this time it has been clear that what is the performance measure usually means. But I think I've started this topic by the name known as King Midas. And why I'm telling this, that what is the King Midas? This why is it, why this is known as a King Midas problem, is um, that we should accept the possibility that we might put the wrong purpose into the machine. And that I think that should be inherently understandable by us also, that even though we do our best to decide that what is the best performance measure, sometimes we can put a certain performance measure which might not be good for the which might for the long run. Okay, and one other thing is the okay, and this is known as the King Midas problem. And what it usually means, that we know that in all of the various culture that we find across the globe, we have humans who ask God or genies or magicians or whatever you can call devils. We find that in all of those stories, they get what they literally ask for, but then they regret it. The third wish, if there is one, is to undo the first two. Hmm. So the thing, so let's say, so the king Midas actually was king in Greek mythology, and and what he demands to the god, that ask that he wanted to, that whatever he touches turns into gold, but then regretted it after touching his food, drink, and family members and whatnot. And then and there could be third wish, that it can undo the undo its particular wish. But the thing is, yeah. So this kind of problem is known as the King Midas problem, in which first you put a particular performance measure, and but then it it should be inherently understood by you that that we might put the wrong purpose into the machine, and how the machine is understand a particular performance measure. Even though we have diligently assigned a performance measure, we should accept that we might put the wrong purpose into the machine. And this is how what is known as the King Midas problem, that even the you wanted gold on the first hand, but then you regret it afterwards. Okay, so I think this is all understood with the performance measure, and I will end this particular video by defining that how what actually are the rational agents. Hmm. So, given what we have understood so far about the agents, what are the performance measures and everything, a rational agents can be defined as that for each possible percept sequence. So you know that we have what the agents do with the help of sensor. It perceives certain particular condition of the environment, not only the current condition but also the past history. For each possible percept sequence, hmm, what the agent should do, a rational agent should select an action that is expected to maximize its performance measure. So for each possible percept sequence, what does the rational agent will do? Will generate a sequence of action. Will generate a sequence of action, hmm, in such way, in such a way that maximize the performance measure. That max the performance measure. Okay. But at the same time, given that the evidence provided by the percept sequence and whatever built-in knowledge the agent has. Okay. So it means this particular action, whatever the sequence of action that is being generated, is not on the basis of some unforeseen percept. It is on the basis of whatever the current condition and whatever the past knowledge that the AI agent has about the environment. Okay. So this is how we define actually the rational agent. That for each possible percept sequence, a rational agent should produce a sequence of action in such a way that maximize the performance measure, and it has given these sequence of action on the basis of current condition of the environment, as well as its past knowledge of a past built-in knowledge about how the environment has behaved on various actions of the agents. Okay, so that's how we define the rational agent. Okay, so this was a lot of theory, I think, but yes, we I think this is second last video in the context of theories. There will be one more video in which I would go a little about the more theoretical aspect of the AI agents, and then we will go purely on the implementation basis, that how the AI agents look like and how you can make your own AI agents, and what are the different code structures, what are the different types, the taxonomies, and all that kind of thing we will going to study in the upcoming videos. But I think yes, in the initial few videos you have to get along with me along on the theoretical aspect of it. So I think we're good with it, and thank you for listening up to this part. Stay tuned, and we will get back with more knowledge about the AI agents. Yeah, thank you.